Hey, this is Bryce and thanks for tuning into my YouTube channel, Jack of Trades. In this video, we're going to do a how-to in creating your own vacuum formed part. And it won't be so much a how-to in the sense that I'm not really one to teach someone how to do it because I'm just learning myself. But I'll show you the steps that I took to go basically from this, which was an idea, to this as a finished product. So let me get into the story a little bit. I think these are made by Proline. It's basically a Lexan vacuum formed RC car stand or work stand, whatever you want to call it. And it's nice. I have a couple of these that I painted up and I use them to support the cars. They are kind of tall, and that's probably the only thing I don't really like about them, is that they're tall. So what I did is I used this as kind of inspiration, and then I modeled up my own stand. And actually this video will go through from cradle to grave, basically from the idea to modeling, to slicing it and then printing it. So then we printed the buck out of PLA. I glued some spacers on the bottom, and then we vacuum formed it. And then we trimmed it, painted it, and threw on some decals, and it actually came out really nice. Well, the vacuum forming is not perfect. There's lots of lines. I could go back and smooth out my buck because those lines kind of project through the material, and I've got wrinkles. But you know, for a learning piece, it's okay, and it's functional. So what I like is that it's shorter, and it just gets. I'm using the King cab as kind of my benchmark or my reference. As I think this is one of my taller trucks in my collection. Not including the monster trucks, but when it comes to kind of the vintage cars, buggies, stadium trucks, this is one of the taller trucks. So I'm using this to kind of gauge my ground clearance, and this stand works perfectly. It gets the vehicle just off its wheels, where they're just barely hovering over the ground. So yeah, it's a perfect height, I think, for this and anything smaller. So yeah, that's what we're gonna discuss in this video. Thanks for tuning in. Alright, so I'm using Solid Edge to model this part. I start with the base of the stand, which is a simple rectangle, and then I do the riser, which is a bunch of circles connected by radiuses, and then kind of messing around with the shape to try to get it right. There's not really any science behind this, it's just whatever looks good, using that Proline part as inspiration. Once I get the shape right, I will then extrude it to about 2 inches high, and then I will put a loft on the faces. We want the loft because we're doing an extruded part, or a formed part, and this will help release the buck as well as give it some integrity. And then I cut out a pocket on top for the parts tray. And once I'm done with the cutout on top, I then put a bunch of fillets or radiuses on these sharp edges, just to make it look nice. And that's about it. The whole part took, I don't know, about 40 minutes to model, so it didn't take too long. I do put a bunch of holes in for vacuum pumping on the mold. Alright, so my 3D printer is a Prusa, so I'm using the Prusa slicer to slice my models. So I'm going to go ahead and bring in my car stand model. Alright, so we see that it comes in small. That's because I modeled in millimeters, and this is probably looking for inches. So we just need to scale that up by 25.4. We're already at 100% scaling factor, so basically 2540. Alright, and that looks good. So now let's check our settings. I want to check my perimeters. I want my perimeters to be 3. And then I want my infill to be gyroid, not grid. Gyroid. And I'm printing in PLA, which is fine. I'm doing a 0.15 speed,
And let's see here, what else? 20% infill. I think we look good. Let's go ahead and slice it and see how long this print's going to take. I would guess 20 hours. But it could be longer, it could be shorter. Alright, so the slicing is done. Now it's calculating, generating G-code. Let's see how much material it's going to take as well as how long it's going to take. So there it is. 1 day, 14 hours, so basically 40 hours to print this. It is what it is. And how much material? Here's 126 grams. So we're using about a third of a spool to print it. What can we do to make this? We can change our infill, so we can reduce that to 15% to reduce material. I can make my layers thicker, so we'll go 0.2 millimeter. We'll transfer our settings over to there. Go and slice it down and see how that changes. Alright, we should have an answer here shortly. It's a big part, you know, so if it takes 40 hours, that's fine. I'll print for 40 hours, but let's see if we can get it under 24 hours. So that by tomorrow, this time we have a part or a buck that I can use to vacuum form on. Alright, so there we are. We're down to 21.5 hours, and then we're only using a little less material. So I think we will try this print and see how it goes. I'm going to go ahead and export that G-code and save that to my memory card, and then we'll go to the printer and start printing.
Alright, so our buck is done, and then I went ahead and glued some spacers onto the bottom side of it, just so I can get a good part line, I guess. Actually, no, that's not what I did. I did it because I wanted to make sure I got flow through my little vent ports that go through the mold or the buck. So the way this works is there's a heating element in the top here, up above, and then you have this frame that you sandwich your plastic in this lower frame there. There's the lower frame, and then there's an upper frame, and then you clamp those together, and then you raise it up, and then it heats the plastic until, I mean, it has a timer on it, but really you're just looking for an appropriate amount of droop in that plastic, and then you bring it down on top of the part, and doing that you turn on the vacuum on. So the vacuum is really loud. So right now we're waiting for that heating element to warm up, and then we will try to pull apart. Alright, so we are at temperature, so first thing we'll do is we'll put our material in. So, then on the top frame, we lock that down. Then we raise it up, and it starts our timer. Alright, now we're ready to pull. That was an okay pull. They didn't get all the way down to the corners. You probably need to let it heat up a little more. So here's our, but the pocket pulled nice, a little recess. So let's try another pull and see if we can get a little more definition on that. Alright, we'll do one more just to see how it does. In reality, I need to make a bunch of these, so I do need to get some material though. So that's the material, and we're looking for it to sag. You can kind of see it start to deform, or it's already started deforming, but we want it down as low as possible so we get a good pull. That This is kind of a learning process. You figure out what works. That looks good. Alright, so there's our vacuum form part. There we go. And we have a nice line to trim to. So we can clean this up. So let's go and do that. Alright, so the next step is just to do a rough trim on it. Make it a little manageable. And then we can come back and trim it with some poly scissors. Alright, so in closing, the process worked well. I was very happy with it. I do have there's still a learning curve on making bucks and kind of pulling good vacuums, or good parts, vacuum form parts. I do need to go back and smooth out that buck so that I don't see the lines that, I mean the worst is on the back side here that projects through. But as far as functional parts, it works great. And you know, if I can crank out a stand every couple minutes, that's perfect. Because I mean, originally I've been thinking about a good RC car stand for a very long time. From doing kind of wood ones to doing like a jigsaw wood type that you build up to plexiglass to 3D printed, and you know, 3D printing would be kind of cool. I can make it much less material than that buck, but if I can make a stand where I can crank it out in a couple, you know, one every couple of minutes, because I need to make probably 20 stands or so. Vacuum forming is the way to go, I think. The other nice thing is that you can, or I can customize them, right? Because I can paint each one, I can throw stickers on it, I can even put labels on them if I wanted to. There's a lot of real estate on this. In this design, there's a lot of real estate to do something with, right? The other thing I want to mention is, so in this design, you know, when you have cars kind of on the shelf, sometimes you're hunting for parts or it's a project in the works. So I wanted to kind of build this little parts tray in the bottom of it. So as you get parts in, you can kind of store them in this little cubby. You can also put them underneath the stand, but that's what this pocket here is for, is basically just to hold little parts and knickknacks associated with whatever car is on display. So yeah, I'm happy with it. I think it'll look great once I get a couple made and get the cars resting on the shelf. And you know, and of course the primary function is you're getting those cars off the wheels so that you don't get flat spots on the tires, which will happen over time. And you're not gonna scratch up or damage the chassis either. I just put on some foam tape here to give it a little bit better grip so it's not sliding around so much. But yeah, thank you for watching to the end and tuning in. I appreciate it. Have a good one. Take care.